All right, the next section for this unit is over 4.3, which is the linear correlation coefficient. Okay, a lot of the calculator stuff we kind of already went over the last unit, so some of it will be a review. Make sure you have the guided notes for 4.3 to make this a little bit easier. Okay, so first thing we're going to go over is just what the correlation coefficient R is. Okay, so we kind of talked about this. Remember, this is just the R variable, and it measures the strength.
You found something over there?
Yeah, I just got a couple of there now.
That?
And direction
I just happen to know that's permanent.
That's permanent.
Yeah, I don't know about that.
of the linear relationship.
Yeah, just
Yeah, I told her that.
okay.
I told her I'd make it sound for just a second. What's this one?
Okay, the one thing about correlation coefficient that we need to know is make sure you know that it does not tell you anything about cause and effect. So just because two variables increase or decrease together doesn't mean that one is affecting the other to increase or decrease. Okay, so in an example over that, it says over the past few years, there's a strong correlation between sales of diet soda and traffic accidents. So they're asking if drinking diet soda causes traffic accidents. So even though they both increased, obviously one of them does not cause the other one. So there is no correlation between those two. So when it asks what third factors, it could be anything. We'll just say maybe an increase in population. Okay, so just make sure you know that just because two things are increasing, so sales of diet soda and traffic accidents both increased, they had no effect, one had no effect on the other one. Okay, the strength of the correlation, we kind of covered this already. Remember, the closer R is to 1 or -1, the closer the points are to a straight line. Remember, +1 means positive slope, -1 means negative slope. Okay, these examples are not on your sheet, but these are the ones we talked about last time. So here, not close to a straight line, so R is far away from 0, all the way down to we're very close to a straight line, so it's close to 1, but it's a negative slope, so it's negative. Okay, now the coefficient of determination, this is R squared. Remember, R and R squared come from your calculator. And it measures the proportion of variation in Y that is explained. So whatever number they give you for R squared is going to be a decimal. So after we convert that to a percent, that tells us the percentage that is explained. So to find the percentage that is unexplained, we're going to take 100 minus the R squared number as a percent. Okay, and we'll do an example so it should make a little more sense in a second. Okay, so remember on the calculator, we're just going to briefly go over it. So we're going to enter everything into L1 and L2. And then we're going to go to Stat, over to Calc, and then we're going to hit 8, which is the linear regression A plus BX. Okay, and then remember, if R and R squared do not appear, then we're going to go to second, 0, diagnostic on, and then we're going to repeat. Okay, but since we changed that the other day, you should not have to do steps 3 and 4, but just in case. Okay, so a quick example. If R equals 0.90 and R squared equals 0.81, we want to find the percent of the variation in Y that is explained by the linear relationship. Okay, remember both of these numbers will come from your calculator. So if we're looking for the part that is explained, remember we're looking at R squared. So I'm just going to ignore R. So if I'm looking for the explained, I need to write this as a percent. So instead of 0.81, if I write it as a percent, that's 81%. So that means 81% is explained. So then to find the unexplained, I'm going to take 100, always 100, minus my explained. So that means my unexplained is 19%. Okay, so we have 2 short examples. Okay, so this is over auto accidents and age. Give you 1 second to read it. So first thing we're going to do is draw a scatter diagram. So up here, X is the age of a driver. And then Y is the percentage of accidents. Okay, so this is what we did yesterday, just the scatter plot. So X is 37, that means Y is 5. I'm going to graph that point. X is 47, Y is 8. Okay, go ahead and graph all of them. Okay, so once we drew the scatter plot, now it wants us to estimate whether R is closer to -1, 0, or 1. So remember, if it's closer to 1, it means it's closer to a straight line. 0 means it's nowhere close to a straight line. So if I just estimate the line of best fit, I'm not going to find the averages, I'm just going to roughly draw one. It would look something like that. Okay, so all of these points are fairly close to a straight line, so I'm going to ignore the 0. I'm going to say it's 1 or -1. So my line of best fit has a positive slope, so that means it should be closer to 1. If my line was a negative slope, then I would say it should be closer to -1. Okay, so now we need to calculate R and R squared. So I'm going to go to my calculator. I'm going to enter all the values into list 1 and list 2. So if I go to stat, I'm going to select enter for the edit. Go ahead and clear your list. Under L1, enter all the X values. So I have 37, 47, go all the way to 87. Under L2, enter your Y's. Okay, so now we're going to go to Stat, over to Calc, and then I'm just going to hit 8, and then Calculate. Okay, so right now I don't need the A and B, all I need is R and R squared, so I'm going to start with R. Okay, so R is equal to 0.9428. Okay, remember R tells you the strength of the correlation. So since this is very close to 1 and it's very close to a straight line, that means that there is a strong positive correlation. Since R is positive, we're going to throw in the positive there. So it's close to 1, so it's strong. It's a positive number, so it's positive. And then we get R squared is equal to 0.88, and I'm going to round to 3 decimal places, so 0.889. So remember that R squared tells you the explained and the unexplained. So this means that if I write R squared as a percent, I get 88.9% is explained. And then for the unexplained, I'm going to take 100 minus 88.9, and we get 11.1% is unexplained. Okay. All right, last example. Okay, so here they give us the data. We don't have to do scatter plot or anything. So all we're going to do is go straight to the calculator. Okay, so I'm going to go to my list. So go to Stat, Edit, Clear Your List. Under List 1, enter all your X values. Okay, so I want R and R squared, so I'm going to go to Stat, over to Calc, and I'm going to hit 8. Okay, so this tells us that R is negative 0.989, and then R squared is 0.979. Okay, so R, remember this tells us the type of correlation it has. So since this is negative, we know we're going to have a negative correlation, and this number is really close to 1. So again, we have a strong correlation. So we have a strong negative correlation. And then remember, R squared tells us the percent that's explained, and then we have to find the unexplained. So here, 0.979 as a percent is 97.9%. So that means 97.9% is explained. So to find the unexplained, we're going to take 100 minus 97.9, and we get 2.1% is unexplained. Okay, that's all we're covering today. So you have the rest of the time to work on your homework. Make sure if you had any questions or you're confused, you email me, please. Here's your homework assignment.